MBI, mission-inspired, market-driven, biotech de-risking. AFEX, which stands for Ammonia Fiber Expansion, was invented by Professor Bruce Dale, a world-renowned researcher in the development of chemical engineering at Michigan State University. AFEX uses ammonia to treat agricultural biomass, the leftover leaves and stalks of the plant. Moist biomass is combined with a specific amount of ammonia at moderate pressure and temperatures and then soaked for a specific time. The pressure is released and the ammonia is recovered and reused to treat further batches of biomass. As a result, the biomass microstructure is altered and the sugar polymers are partially unwound and loosened from the indigestible portion called lignin, rendering the sugars more accessible. AFEX can increase sugar excess substantially. While only 20% of the sugars are easily accessible in untreated biomass, the accessible sugar quadruples to 80% as a result of the AFEX treatment. Another unique feature of AFEX is that the treated biomass is pelletized to increase its bulk density by a factor of 10, resulting in grain-like handling characteristic and improved transportation economics. AFEX pellets can be used as either a cattle feed ingredient or a biorefinery feedstock. In cattle feed applications, the pellets break down in the rumen to release sugars and provide a nutritional energy source similar to that currently provided by grain. As a biorefinery feedstock, the pellets are treated with enzymes to release sugar, and the sugars are converted via fermentation into products such as biofuels and bio-based chemicals. Round bales of raw biomass are brought to the MSU dairy farm where they are stored under cover. The round bales are coarsely chopped using a bale chopper, which reduces most of the material length to less than 2 inches. The chopped biomass is loaded into super sacks. This is a dusty process and a dust mask must be worn. Bags are loaded into a truck and hauled to MBI. In a shed built at MBI, there is a ribbon blender where the biomass is unloaded and water is added to adjust the moisture to 20%. The biomass is contained in metal mesh baskets that were custom made for the reactors. A calculated volume of biomass is compressed to achieve target density. Baskets are then filled and compressed. The baskets are weighed before going into the reactor. 7 baskets filled with pressed biomass are loaded into the reactor. The head of the reactor is closed using 7 T-bolts and are torqued to 250 foot-pounds. Ammonia is brought to MBI by a tanker truck. There is a 1,000-gallon ammonia tank for the AFEX reactor at MBI. The ammonia is pumped into the reactors using a piston pump. Ammonia masks are worn when inside the cubicle of the reactor when ammonia is present in the system. The ammonia goes through a steam-jacketed heat exchanger when charging the reactors. The AFEX packed bed concept treats moist ground biomass in packed beds using 5 steps. Step 1, pre-steam. Step 2, ammonia charge. Step 3, soak. Step 4, depressurize. Step 5, steam strip. Initially, a bed of biomass will be charged with fresh ammonia immediately after pre-steaming. The first bed of biomass is charged with compressed ammonia to a load of 0.7 kg per kilogram of biomass. The compressed vapor is charged to the biomass until a pressure of 300 psi is reached and allowed to soak. The pressure is allowed to drop to 290 psi and more ammonia added until the target amount is reached. The temperature of the reactor will reach 100 degrees Celsius. This is the view of the HMI after the first bed has been charged with ammonia after soaking for a few minutes. This animation will show a bed-to-bed transfer of ammonia. Pre-steam and soak. The lead bed is the bed that contains the ammonia. The lag bed is the bed that will be receiving the ammonia. Pre-steaming serves to both preheat the biomass beds and displace the entrained air. During pre-steaming, steam pressure at the top of the bed is less than 3 psi, and the bottom valve is open to allow the air to be displaced. The temperature will rise to 80 degrees Celsius. A bed will have been soaked for at least 30 minutes. Ammonia charge and depressurize. During a bed-to-bed ammonia transfer, ammonia from the lead bed will be transferred to the lag bed. At the end of the soak period, the pressure from the lead bed will be released to the lag bed. An ammonia compressor is used to pull down the lead bed pressure. Ammonia charge and steam strip. Approximately half of the ammonia is transferred to the bed upon depressurization. This residual ammonia is removed from the bed by direct steam stripping. The vapor is driven off the bottom of the bed and sent through a condenser and trapped to the compressor suction, and the compressed vapor is sent to the next bed in the series. Steam stripping is complete when the bottom temperature of the lead bed is 100 degrees Celsius. After this bed is treated, the baskets are removed using a chain hoist. A new set of untreated biomass is added to the reactor. After a bed is treated, the baskets are weighed again. The treated biomass is emptied into porous burlap bags and dried in an oven at 45 degrees Celsius overnight. The dried, treated biomass is mixed together in the ribbon blender, and if necessary, the moisture is adjusted to specifications of the biomass. The treated biomass is pelletized using an 8-inch flat die pelletizer. The pellets are further dried and then bagged.